All right, this is our first SAT question in depth. And this is from practice test 1, question 7 on the non-calculator. And my nickname for this question is monthly payments, reciprocals, and custom equations. So let's take a look. So the question here is a monthly payment formula. This is the formula that actually your loan officer or a finance manager at your car dealership, the computer program that they're using. And it looks very complicated. So the question is asking, which of the following gives P in terms of M, R, and N? So take a look at this question here for a second and see what you can figure out. One thing that you might take away is that you want to get this P all by itself. But it looks kind of confusing. So I'm here to help you out. So we're actually going to break this problem into a much simpler type of problem. So this first question is saying that if we want to get P equals 1/2 M and we want to get M by itself, what are we going to do to get M by itself? So it turns out that the opposite of 1/2, or 1 divided by 2, and notice how I said 1 divided by 2, is to simply multiply by 2. And those 2's cancel out. And I am left with M equals to 2P. So then in part B, I'm going to make something a little bit more complicated. So it's P equals to 2/3 M. And I'm going to ask myself, how can I get M by itself? So for this, there's this property that says that if you multiply a fraction by its reciprocal, you can get variable by itself. So it turns out that 2/3 times 3/2 cancels out very nicely. And what we are left with is that M is equal to 3/2 P. And in the next question, I just ask you, what is the reciprocal of 2/3? So we call that 3/2. So these are the underpinnings of the big bad question that you are about to see. So now we're going to extend this idea of the reciprocal, which the reciprocal just simply means we take A over B and we flip it to B over A. And we're going to extend it to this big bad SAT problem. So here we are for D. This says, based on your logic in part C, what is the reciprocal of this fraction? So when we do that, we just simply flip the numerator and the denominator. So let's take a look here at what this is showing. So we're going to put the 1 plus r over 1200 to the n minus 1 in the numerator. And then on the bottom, we're going to put r over 1200 times 1 plus r over 1200 to the n. And there is distinctly one answer choice in which we have that. And that answer choice is B. So if we go back to the question here and just kind of look at it again, you know, we want to get P by itself. So that's our goal. Basically, if we multiply by the reciprocal, and this is why it works, and we do this on both sides. So I'm going to r over 1200 to the n minus 1 over r over 1200 times 1 plus r over 1200 to the n. And I just multiply that on the other side as well. I can see that there will be a lot of canceling that goes on. And here's how. So this r over 1200, this numerator cancels with that denominator. And this denominator cancels with that numerator. And the only thing that I'm left with is P. And lo and behold, my answer choice that I'm left with is B. So just a little recap here. Takeaways of this question. First of all, I think it is warranted that this question is on the SAT. How real can this get? So I've actually seen finance officers and mortgage officers enter numbers into computer programs to see what your monthly payment is. And it turns out that this is how your monthly payment is computed, you know, with formulas like these. So you better know how these formulas work. And this question is based off of a simple mantra that we see in math. For every operation, there is an equal and opposite operation. So we can multiply by the reciprocal to get rid of a fraction. So that's actually a pretty simple idea, but this is probably one of the most complicated ways that you are ever going to see this simple idea be assessed. And because of that, I give this the highest Benzel score in difficulty of 4 stars, simply because the problem looks a lot more difficult than it really is, and it's likely to throw off many students. But at the end of the day, if you get to the root of the reciprocal, you can get this problem correct.